All right, next we're going to be studying parallelograms. So in our first set of notes, we're just going to look at the different properties and kind of fill in the blanks. And then once we get to class, we'll actually look at how to use those properties within math problems. So first, we're going to go ahead and label this parallelogram as parallelogram ABCD. So in a parallelogram, opposite sides are parallel and equal in length. And when they are equal in length, that means that they are congruent. Their sides are congruent. So when we say that they are parallel, we draw these little markings, parallel, and we would say that AB is parallel to CD. And then we would draw these little markings, two of them, that BC is parallel to AD, like that. And then to say that they're equal in length, we would do one little marking like that. AB is congruent. It's the same length as CD. And BC is congruent to AD. So that's how we draw, or that's how we write that in shorthand notation, so you don't have to write the sentence every time. The opposite angles are congruent as well, or you could say they are equal in measure. So the opposite angles are like A and C. So we're going to say angle A is congruent to angle C. Those are opposite angles. The other opposite angles are B and D. Angle B is congruent to angle D. Consecutive angles are supplementary. The word supplementary means that they add to 180 degrees. So consecutive angles are angles that are next to each other or angles that are in a row. So we're going to say the measure of angle A plus the measure of angle B equals 180 degrees. I'm not going to write out all the combinations, but these two add to 180 degrees. 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 Next, the diagonals bisect. They bisect each other. They cut each other in half. So we're going to go ahead and draw in these diagonals. So here are the diagonals. I'm trying to draw it as perfectly as I can. All right, so there's our diagonals. They cut each other in half, so 1, 2, 3, 1, 2, 3. Those are the same measurement. And then we've got 1, 2, 3, 4. 1, 2, 3, 4. Those are the same length as well, so they bisect each other. I'm going to go ahead and label this right here as E. So I'm going to say, running out of space kind of, so I'm going to say BE is congruent to DE, and CE is congruent to AE. All right, so those diagonals, they bisect each other. All right, so that is true of all parallelograms, all of those things, okay? And then as you can imagine, when we're actually doing math problems, all of these things, we could have numbers in there. We could solve equations based off of that. We could have a number here and find a number there. We could have a number here, find a number there, all sorts of different things that we could do based off of these properties. All right, next blank, a rectangle is a specific type of parallelogram and has all of the same properties as a parallelogram, and every angle is 90 degrees. So that's something specific. It has all of these properties are the case, but the angles are 90 degrees and the diagonals are congruent. So if you look at this picture of a parallelogram, it looks like this is a longer diagonal and this one's a little bit shorter, but they bisect each other. In a rectangle, all of this stuff would be true, but you're kind of shifting it. It's straight up and down. The angles are 90 degrees and the diagonals are actually the same exact length. They still bisect each other though. Next, a square is a specific type of parallelogram and a specific type of rectangle. And it has all the properties of parallelograms and rectangles, and all of the sides are equal in length. The diagonals bisect the opposite angles, and the diagonals are perpendicular to each other. So when you're talking about a square, all this stuff is true, and this stuff is true, and we got some more properties. So you got a little bit more that's true. All right, a rhombus is a specific type of parallelogram and has all the same properties as a parallelogram, and all the sides are equal in length. The diagonals bisect the opposite angles, and the diagonals are perpendicular to each other. I've always thought of a rhombus as a square that's been stepped on, so it's been like slanted a little bit, but it's very similar to the idea of a square. Not quite a square, but kind of similar. So when these are kind of interesting things about parallelograms, that they're kind of similar, they're like specific examples of parallelograms. But when we talk about parallelograms in this class, we're actually going to be focusing in on this stuff.